Okay. Um, this is just a quick crash course on balanced and unbalanced forces, also known as the net force. You heard me in the last section referencing the term net force a few times, but I only showed you one or two examples of actually calculating that net force. That would be the example with Tarzan and the ape and the pushing and pulling forces there. So, to recall from Newton's laws, balanced forces will always result in uniform motion. Uniform motion means that the velocity is constant. And that can be a constant value. It can also be zero, right? It can also stay with no velocity. So a constant velocity is uniform motion. If the forces are balanced, that means the net force is equal to zero, then you're going to get uniform motion. If the forces are not balanced, if you have unbalanced forces, then you will always get accelerated motion. That means that the velocity is changing. So what the net force is a vector sum of all the forces on an object. For example, if I have 5 newtons west and 3 newtons east pulling on an object, the net force, you don't have to show your work for this, it's just obvious that it's going to be 2 newtons west. That's all I'd expect for a question like that. It's not really a proper free body diagram, but just trying to show you how to calculate the net force. Same sort of thing. 3 newtons up, 12 newtons down will give you a net force of 9 newtons down. Same rules apply for vectors. The direction goes in the square brackets. Now just our units are in newtons because it's a force. Now on the third example here, you've got 4 forces, but luckily the up and the down forces, or the north and the south forces, cancel each other out. 5 up, 5 north, and 5 south go to nothing. So all you got to do is think about the 2 newtons east and the 8 newtons west, and all you'd have to write for that is that the net force is equal to 6 newtons west. So that all seems quite easy, I'm sure, for all of you. But this right here would represent the toughest task that you'll have to perform here. Because the forces are balanced in both the north-south or the y-axis and in the x-axis. So first I'm going to deal with the x-axis. I'm going to say that, okay, the 12 newtons west and the 15 newtons east give me, at least in that direction, 3 newtons to the east. The 15 is greater than the 12, 3 newtons to the east. To that, I have to add the unbalanced force in the y direction. And in the y direction, the unbalance is 6 newtons north, 10 newtons south, so it's going to be 4 newtons to the south. The answer, the actual net force to this question, is that hypotenuse to this right angle triangle right there. And it's quite easy to get the value. Everybody knows how to find that. Why don't we label that as F net, because that is what the net force is. And so I'll say F net squared equals 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. So I know that the answer is 5 newtons. I don't know the direction, but if you recall from our vectors unit, that if I draw my diagram east and then south, then my direction is going to be east and south. Then I just have to find this angle, which is opposite over adjacent. So it's going to be the tan of the angle I'm looking for is equal to 4 over 3. If I punch that real quick into my calculator, 4 divided by 3 is 1.3 repeat. And then I have to do the inverse or shift tan, which is 53 degrees. That is the answer to this problem. That's about as difficult as things are going to get in this lesson here. So now let's revisit Newton's second law. That's the one with the equation. That's the F net equals ma, or you might recall me writing a triangle where I had F net in the top, mass, and acceleration. So both the force and the acceleration are vectors, and so they have to have a direction with them. A 1,500 kilogram car applies the brakes and causes an unbalanced force. That's a net force of 250 newtons on the car. What's the acceleration of the car? If I arrange that formula to solve for acceleration, it's going to be F net divided by mass. So that's 250 newtons divided by 1,500 kilograms. Type it into your calculator. 250 divided by 1,500 equals 0.17 meters per second squared is the unit for acceleration. Now, you might notice that newtons divided by kilograms, though, gives you newtons per kilogram. Now, that's also a valid unit for acceleration, and they actually mean the same thing. Meters per second squared and newtons per kilogram are the same. Example 2. What force is required to get a 12 kilogram mass accelerating at a rate of 5.5 meters per second squared? F net equals mass times acceleration. That's 12 kilograms times 5.5 meters per second squared. Type that into your calculator. 12 times 5.5. And it gives me 66 newtons. That's how you do that one. All right, so that should seem pretty easy. 3 variable formulas usually are, but now we've got something different. 12 meters per second speeds up to 22 meters per second in 7.5 seconds, gives you the car's mass and says find the acceleration. So that looks weird. That looks like linear kinematics, right? It's got a v1, a v2, and a time, and a mass. Well, we know that we can find the acceleration by going net force divided by mass. All right, so the mass is 2,500 kilograms, but we don't know what the net force is. We don't know what that net force is. Actually, it wants me to find the acceleration and the net force. So before I begin this, I have to find that acceleration. So I'm going to do this as 2 separate problems. It's a simple problem, but it'd be worth a lot of marks on a test because you have to set up 2 equations and solve for 2 different things. So first, let's go. We've got v1, v2, and time, and we want to find acceleration. So if you look on your formula sheet, that'll be v2 minus v1 over time. So that's 22 meters per second minus 12 meters per second divided by 7.5 seconds. If you type that into your calculator in the correct order, 22 minus 12 is 10, and then 10 divided by 7.5 is equal to 1.3 seconds. Meters per second squared. So that's my acceleration. Now, if I go back over here and I set this up just a little bit more nicely to solve for the net force, I'm going to go F net equals mass times acceleration. We know the mass is 2,500 kilograms, and the acceleration we know now is 1.3. It was actually 1.3 repeat on my calculator, so I'm just going to leave that value on my calculator, and I'm going to multiply it by 2,500, which gives me it gives me 3,333, but if I want to round my answer to, let's say, 2 digits, because that's what I started with, that will be 3,300 newtons of force. So as you can see, there's a lot of things to set up there. It would be, if I want to make each side out of 3, I suppose that makes sense. So it's a big enough question to put on a test. And now for the biggest one of all, you've got to use a whole bunch of skills from this particular note and the last note on Newton's laws of motion. Gives me a mass, 5 kilograms. Gives me a whole bunch of forces on that mass. And it says find the acceleration. Well, acceleration equals F net over mass. We know that the mass is 5 kilograms. But again, we don't know what the net force is. We can find the net force from this diagram. Again, I'm going to start with the x direction, the east and the west, and I'm going to say that, okay, so there's the unbalanced force there is 6 newtons to the east. The unbalanced force in the y direction, I've got 6 newtons north and 3 newtons south. So that is going to be 3 newtons north. The answer, the F net in this problem, is right here. Just like you did before, use Pythagorean theorem and say, okay, so F net squared equals 6 squared plus 3 squared, and then make sure you square root it after that. So in my calculator, I go 6 squared plus 3 squared equals square root equals, and I get 6.7 newtons. That's good, but I also need the direction. I need this angle right in there. Opposite over adjacent, tan of the angle is going to be equal to 3 over 6, and the angle is going to be 3 divided by 6 is 0.5. Shift tan is 27 degrees. I'm going to round that to the nearest degree. So when I write this net force in here, I'm going to write 6.7 newtons, and I'm going to write east-north, east 27 degrees north. When you're dividing by a scalar like mass, it doesn't change the direction at all. So I go 6.7 divided by 5 is 1.3 meters per second squared. And then the angle is going to be east 27 north. All right, that is the answer to this problem right here. That is by far the biggest question you'll have to do in this particular lesson. And again, it would be worth quite a bit. There's quite a bit of work you got to do here and quite a bit of work you got to do here. So those last two are really good examples. Hopefully that's enough to get you going on the practice sheet. I'm not going to post anything tomorrow. I just want you to work on as many of these questions as you can. Maybe even until the end of the week. I might post one other short lesson on Friday, but beyond that, but other than that, I just want you to practice these questions. Any of them that you can't do, I don't want you to spend more than a few minutes on each question. If you're stuck and it's taking you too long, just email me through Classroom, and I'll tell you how to do it, and things will go a little bit more smoothly. Okay, do all the ones you can do, and I'll help you with the ones that you can't do. Okay, that's all for now.